Hello, everyone, and welcome back to another MAT 170 concept session. Today, we'll be looking at foiling and distribution rules. My name is Nick, and I work with the ASU Tutoring Centers. So let's go ahead and get started. All right, so we'll go ahead and look at the problem on the left-hand side of your screen. We're giving two different equations, an f of x and a g of x, and what they'd like us to do is find the product of the two. So the way I'm going to just kind of start is just to kind of plug things in first off. So we have f of x and g of x. And what we can do is just kind of plug in what they give us as f of x and g of x. So I'm going to put them in parentheses. So we have x plus 5, x plus 4. And the reason why I do that is because technically what they want you to multiply are like these kinds of like answers, right? So the f of x and the g of x. So like if you plugged in 1 to x plus 5, you'd get 6. Plugged in 1 for g of x, you'd get 5. And then you would multiply those two answers together. So that's why we have them in parentheses here, because we still want them in terms of x. Cool. So the way we're going to multiply these two functions together is by a process called foiling. So what that is it's FOIL. And they each stand for something. So for the F, it stands for first. O stands for outer. I stands for inner. Oh, there we go. And then L stands for last. Cool. Okay, so the way we're going to do this in terms of multiplying the two functions together is we're just going to first off do an example. So for first, what you would do is multiply the first part of the f of x times the first part of the g of x. Now what outer means is the first part of the f of x times the second part of the g of x. Hopefully you're noticing a pattern here. So then for inner, it's going to be the second part of the f of x times the first part of the g of x, and then the second part of f of x times the second part of g of x. Now, if we write it all out, we have x times x plus x times 4 plus 5 times x plus 5 times 4. Now, continuing to solve, we have x times x. So in this case, what we would do is just keep the x and then add the exponents together. So for each of these exponents, it's to a power of 1. So 1 plus 1 is 2. Then what we're going to do is just combine the 4 and the x. So we have 4x plus 5x plus, and then 5 times 4 is 20. Now, before we kind of call it quits and say that this is our answer, we need to check through what we have and make sure that the x variables all have different powers. And if you can see, we have this 4x here and this 5x here, and they have the same power. So both of their x's that the 4 and the 5 are attached to have a power to 1. So what we can actually end up doing is add the 4 and the 5 together and do what's called combining like terms. So what we can do is rewrite the x squared, and then 4 plus 5 is 9, so we'll do 9x plus 20. And since now we don't have a variable with the same power, we can call this our final answer. All right, so now we're going to do the same thing on the right-hand side. So we still have f of x and g of x, and they want us to multiply it. So what we'll do is rewrite the f of x and g of x, but plug in those equations, just like what we did over here. So for f of x, we have x squared plus 2 times 3x plus 1. All right, and then from there, what we'll do is the same exact process, right? So we'll do first, outer, inner, and then last. Sorry about that. All right, so now we have x squared times 3x plus x squared times 1 plus 2 times 3x plus 2 times 1. Now doing some math and kind of recalling what we did for the last one, we have x squared times 3x, right? So we're going to want to add the powers together of the variables. So we'll have x cubed here, 2 plus 1, and then we'll keep the 3. Then we have x squared here. sorry about that. Let me go ahead and erase that. There we go. So we have x squared, and then we have the imaginary 1 to the left of it as its coefficient, plus, and then we have 2 times 3x, which would be 6x, plus 2. And looking at through our answer, we have no variables with the same power, so we know that we're done. Perfect. Okay, well, hopefully that was a good overview of this concept for you. If you have any other questions, feel free to visit tutoring.asu.edu for more information on the tutoring centers and also like hours of operation as well. We have tutoring centers on all 4 campuses of ASU, as well as an online tutoring center that you can check out. All of these resources are free with being an ASU student, so definitely take advantage of them. If you enjoyed this concept video, check out that link on your screen. That'll direct you to a document that lists out all of the other different concept videos for this course, and you can kind of pick and choose at your convenience. But I hope you have a great rest of your day and good luck in your course. Thank you.